There's an article by 3 British scientists in the scientific journal Physical Review Letters that says, in part, a general continuum theory for the distribution of hairs in bundle is developed, treating individual fibers as elastic filaments with random intrinsic curvatures, applying this formalism to the iconic problems of the ponytail. The iconic problems of the ponytail? Where's the problem? Oh, who better to explain than our math guy, Keith Devlin of Stanford University. Keith, this is for real?
Yeah, and this one caught my eye too, Scott. I couldn't believe it. 2 of the authors are actually classical sort of research mathematicians and scientists, one at the University of Cambridge, one at Warwick University. The 3rd author is a research scientist at Unilever. And, of course, Unilever makes hair care products, and we're talking about a $40 billion global market in shampoos and conditioners. So they got some mathematicians to come up with a mathematical formula to understand how to make more attractive ponytails, so that a ponytail curves around in a beautiful, sexy, attractive arc rather than just hanging limply. That's a $40 billion question.
Keith, is there something to be learned here that pertains to something other than ponytails?
Yeah, a ponytail is just made up of many individual hair fibres. So the mathematical question is, how does the shape of that fibre bundle derive from the individual properties of the fibres? Now, there's lots of other things that are made up of fibres. There's fibre optic cables, which are of major importance now in communications transmission. The cables that hold up suspension bridges consist of many strands of steel that are bundled together. So we're talking about mathematics that holds up the Golden Gate Bridge, mathematics that tells us how fibre optic cables behave when they're twisted and bent through conduits. So this is actually much more than a question about hairstyle.
So what's the key to having a fuller, flouncier ponytail, mathematically speaking?
I guess Unilever would like the answer to be we buy their products, but it comes down to those 3 factors of the individual hairs that are important. One is its elasticity, one is its density, and one is its curliness. Now, Unilever can't do much about the density, but they could make products that affect the elasticity and the curliness, and so they now know, with some accuracy, how to affect individual hairs so that the ponytail that someone puts together looks more attractive.
Keith, we've known each other for a few years. I'm just going to bet that you're the kind of guy out there in the Bay Area who, at one or more points in your life, had a ponytail.
I did. It was a fairly short, stubby one, so I wouldn't have benefited from this mathematics. I never got one of those long ones, which would have actually been beneficial, which would have been benefited by this new mathematical formula.
Keith Devlin, our math guy. I can't believe it. Our math guy speaking with us from the students from the studios of Stanford University. Thanks, Keith.
It's my pleasure, Scott.
This is NPR News.